here we go. So the last part of this section is talking about looking at intervals of convergence. Let me try that again. Looking at intervals of convergence. There we go, ratio test. Okay. Now, what's going on with this description? It's basically saying someone hands you a power series. How are you going to attack, and what are you going to find out when you try to find the interval of convergence, or the radius of convergence for that particular series? It says, what it says, number one, use the ratio test. And when we do that, we're going to get an interval. Now, if we're really lucky, it'll be convergent everywhere. A lot of big smiles on our face. Or if we're really lucky, it'll be convergent only at the center for that particular power series. And we'll be done. But there's also the possibility that it has a finite radius of convergence. There's an interval, a non-zero width interval in which it is convergent. After we find the interval, we're going to realize that the ratio test is only conclusive when the ratio that comes out is between -1 and 1. That means the two endpoints where the ratio, it's only convergent when the limit of the ratios is between -1 and 1, which means there's an opportunity to check the endpoints. The ratio doesn't tell us what goes on at the endpoints of the interval of convergence. This basically says when you're done finding the interval, check the endpoints. And that's exactly what we're going to do on the next slide. And the slide after that. And the slide after that. And the slide after that, and then we'll be done. Are you ready?
Yes.
Someone wake up Trevor. Hey, Trevor. Hey. How are you doing? All right, here we go. Here's a series. For what values of x does the series converge? In other words, find the interval of convergence. Ratio test. I think I'm going to get my phone out too. I'll hold it in my hand. Maybe it'll help me stay awake. I'm not sure.
Oh,
No?
careful. Could become self-aware.
If it did, what would it do to me?
You've dropped me too many times.
How many times my phone has dropped me? Okay. So, interval of convergence ratio test. What ratio? Okay. It's going to be the limit as n approaches infinity of the n plus 1 term over the nth term. By the way, I'm going to put this in absolute value signs. Our book doesn't do this, but my old textbook does, and I think it makes it a lot easier. Okay, so let's take the limit of the absolute value of those two terms. Well, what is the n plus 1 term in this case? Well, I think it would be x to the 2n plus 1 over 2 to the n times n plus 1. There's the n plus 1 term. And because I'm lazy and I don't want to do it in 2 steps, I'm going to write right after it the reciprocal of the nth term.
So just by doing the absolute value, does that just get rid of the -1?
That's exactly correct. Okay, so there we have it. There's our intermediate stopping point. Now what? What can we cancel? Something with these two? By the way, I'm just going to rewrite this exponent as 2n plus 2. So I've got x to the 2n plus 2 on top. I've got x to the 2n on the bottom. When everything's said and done, I'm going to have x squared on top. Can I do any cancellations here? Not that I can see. If I expand out this term a little bit, I've got that. Is that helpful? I think it's helpful in that I can apply the limit now. I've got a pretty good idea what happens to that term as n goes to infinity.
Why is it a square again?
I've got x to the 2n here, right? I've got x to the 2n plus 2 there. And what do I do when I have something with the same base and different exponents? Subtract the top one from the bottom one. Sorry, the top by the bottom.
Just how you think of that if it was an actual expression.
Can I apply the limit now?
Yes.
What do I get? What do I get when n goes to infinity for that expression? 1. I'm left with x squared. Great. Now what does the ratio test says? It says when that limit, when the absolute value of that limit is less than 1, it converges. I'm pretty sure that that means that x has got to be firmly placed between -1 and +1. And that's a pretty good answer. That's almost complete. Say that one more time, please. It's better than pretty good, but could it be better? And the answer is the ratio test is inconclusive when the ratio equals 1. It's inconclusive. Maybe we could apply a different test to find out what happens when x is 1 or when x is -1.
Wait, why is it 1?
I'm sorry?
Why does x squared equal
Well, sorry, the limit is equal to x squared. The ratio test says when that limit is less than 1, the series converges. So what I'm saying is that limit being less than 1 happens when x is in that interval. Let's play a game. Let's play a game, say let x equal -1, and let's see what happens on the first endpoint of that interval.
Isn't it not even like an option to be equal to it?
Well, the ratio test doesn't tell us what goes on there, but perhaps one of the other tests can. Let's pretend x is -1, and let's see what happens. When I put -1 up in here, I get a series which looks like -1 to the n plus 1 times -1 to the 2n all over 2n. The last time I checked, if you take a -1 and you take it to a even power, it's just a positive. I would say that evaluating this -1, we end up getting the series -1 to the n plus 1 over 2 to the n. And by inspection, do we know whether that series is convergent or divergent? I'm sorry, Ryan? Why?
Because it's just basically 1 over n.
I agree that this is a divergent series.
Oh,
But this one's got that -1 to the n plus 1 power. This is an alternating. This is essentially the alternating harmonic series. Not just that it's like 1 over n, but it's like 1 over n but bopping back and forth, positive, negative, positive, negative. I say this is a convergent series. Which means I go back over to this interval of convergence, and I can put a little line under the that inequality symbol. It converges when x is -1. Let's let x equal 1. What kind of series do I get when that happens? rewrite everything from the original one, except put a 1 in for x. You know what? I think that's the same thing we had before. You know what I think? I think it's convergent on that end too.
Wait, what is that convergent again?
Isn't this exactly the same one that we did here?
Yeah.
Isn't this convergent because it's alternating? It's alternating. And the limit as n goes to infinity of 1 over 2n is equal to 0. So isn't this convergent by the alternating series test? So I say the answer can be made better by saying it is convergent from all the way from -1 to +1. Right? Yes?
I, did like the alternating series test right now, like the alternating like before, so they always said if they were alternating then it wasn't convergent.
I don't remember when we said it was alternating.
Maybe I'm just thinking of like if it's alternating like on the correct. So those are the different things.
Okay. There was this idea that we talked about where our value could go boom, 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 and it's going back and forth like that. That sequence never converges. And a series based on that sequence would also never converge. We say if it's alternating and the values in the sequence go like this, where the values are getting closer and closer to 0, a series made up of that sequence of numbers will converge. So it's two things. It's alternating and it's going to 0. Yeah.
Now, if we say both of these are convergent, if we were to put a there for it, by what are we saying is convergent?
I said it's convergent at -1 because of the alternating series test.
Oh, that's what that.
I'd say it's convergent at +1 also by the alternating series test. Notice I didn't use ratio test because we said before, the ratio test is inconclusive at that endpoint. We need another problem. Let's try another problem. So step 1, apply the ratio test. The limit as n approaches infinity of the n plus 1 term divided by the nth term. Any cancellations?
You'd just be left with n plus 1. All at the bottom of one.
Between this n factorial and then this n plus 1 factorial, we just have an n plus 1 on the bottom? I agree. Anything else?
You'd have 10x then. You'd have 10x then.
Is that right? I got 10x to the n plus 1 on top, I got 10x to the nth. What do we do with those exponents? We subtract them. N plus 1 minus n is 1? Sure. Great. Well, we remember that n factorial is equal to like n times n minus 1 times n minus 2, dot, 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 dot. N plus 1 factorial is n plus 1 times n times n minus 1. And what happens is that the n minus 1, n minus 2 that's here all of that ends up canceling with all of that. The only thing that gets left over is one little spare n minus 1. Can we apply the limit at this point?
Wait, n plus 1 times n minus 1 come in?
I'm sorry?
What were you writing for the factorial of n plus 1? What did those say?
It said n plus 1 times n minus 1 times n minus 2 times.
Okay.
So, can I apply the limit? Well, let's pretend let's pretend x is some finite value. But n is allowed to get really big. Kind of like Google. What happens to 10x as n plus 1 gets really big? Goes to 0? No matter what value I choose for x, and 0 is always less than 1, hey, we got lucky. Therefore, this series converges everywhere. No matter what x I choose, that ratio test ends up being 1. Or sorry, ends up being 0. It converges everywhere. That's good news. Do I have to check the endpoints? Nope. I'll try to be more interesting. Okay, next problem. Ratio test, very good. How's the ratio start again? The limit as n approaches infinity? The n plus 1 term? Divided by the nth term? Can we clean that up? N plus 1 on top, okay. What happens when we apply the limit now? You get infinity? I agree. Question? Well, infinity is always greater than 1. In this case, there is only one value of x where this series converges. What is it? What is the one value where this converges? Why? Well, that series will be a series of zeros. 0 plus 0 plus 0 plus 0 plus 0. We also could say it's convergent there because that's the center of that particular series. So, here's the third case. So we had convergence on an interval, convergence everywhere, or in this case, convergence but only at the center. I wonder what the next one's going to be.
So it's like
that's negative 1. Negative 1. I made it worse. Are we ready to go on to the next one? All right, next one. On your own. Sorry, I'm in pairs. In pairs.
What do you suppose we do first?
Sorry.
Two n plus 2. 2n plus 2. And then we can just multiply that by the reciprocal, so 2n. Yeah, so we can get that.
Then it would just be equals.
So you guys stop growing. You guys stop growing as well. Eventually.
Will that 2n
Everyone
cancel?
uses
Will that 2n plus 2? Will that cancel the 2n?
Well, the two
The thing is that,
Well, because it's like a 2n, then there's a 2n plus 2.
I paid like 200.
So is it just a 2n
I mean, essentially, when we're talking limits, yeah.
You sure?
And Texas and the
I'll sleep.
all right. To quote,
Yes, sir.
to quote,
Oh, wait.
to quote Edmund, what do we do first?
You said what shall we do first?
What shall we do
Okay,
first?
so what we do is we take this, we multiply by 2n over 2n plus 1. So we factor it out. We can't cancel it. We can't factor it out. Right? Yeah, we need to factor the 2n over 2n plus 2 out. And then take the limit, which is 1, which is
What's
equal
that?
to...
What does this end up being?
What does it end up being?
Yeah.
I have no idea. 2 to 4, that sounds about right. Probably 2 to 4, convergent at 4, but not at 2. Something like that.
Yeah.
No, convergent at 2, but not at 4. Anyway, it'll be in the recording.
Okay.
Okay, bye. Have a good weekend. All right, let's blow through this. When we clean this up, what do we get? X minus 3 on top. And I like to write it as 2n over 2n plus 2 on the bottom. That's a terrible, let me try my infinite sign there. Will those cancel? Sure will. What do we get when we apply the limit here? Just 1. What do we end up with? We end up with the absolute value of x minus 3 is less than 1, or between, and then when we solve for x, we end up with 2 and 4. So there's our interval of convergence, but we can do better. I guess we can. Let x equal 2. Let's find out what the series looks like when we're at that one endpoint. I get 2 minus 3 to the nth over 2n, which is equal to the series negative 1 to the nth over 2n.
That looks convergent.
That looks convergent. That looks like a variation of the alternating harmonic series. We declare this to be convergent by the alternating series test. And I put that little line right there.
But for it's not convergent, you would have 1 to the n over 2n.
You are wise beyond your years, Anthony. But let me get everyone else caught up as well. When I put in the other endpoint, I'm going to end up with the series 1 over 2n. And this is divergent because it is a p series
Yes.
with p equal 1. And so there's our interval of convergence from 2 to 4, including 2, but not including 4. Excellent. All right. Now, here's what the book says to summarize all this stuff.
Oh my.
Don't read it. Don't read it. Just think. I've got a problem. I've got this series. I hand it to you and I say, convergent or divergent. Now, there's a couple of different methods to determine. There's the magic 8-ball method. You shake the magic 8-ball. Say, is this convergent? It says, the signs look good.
All signs point to yes.
Or you can follow some other sort of strategy other than the magic 8-ball method. All right? And this is one set of strategies or a way of attacking the problem. You get the series. It says, hey, take a quick look to see if the nth term goes to 0 or not. That's easy to check, right? If the nth term goes to 0, it may be convergent. If the nth term doesn't go to 0, it's divergent and you're done. It says, hey, why don't you check to see whether that series you're looking at is geometric? Is it geometric? If the answer is yes, take a look at that R value. If the R value is bigger than 1 or less than -1, it's a divergent series. You're done. If the R value is between -1 and 1, it's convergent. I can tell you what it converges to. But what if it's not a geometric? It says, hey, maybe it's a P series. That's pretty easy to check to see whether it converges or not. And I'm going to love in there, is it a P series or something that looks like a P series? Because officially, this one series that we looked at just a second ago, officially that's not a P series. It's 1/2 times the P series 1 over n. But we're pretty loose on this. Does it look like a P series? If it does, is the P greater than 1? If it is, it's convergent. If it's 1 or less, it's divergent. What if it's not a P series? It says, go on and check the ratio test. This is where I disagree with the book. What I say is, if you run through these first ones, I'm not going to go to the ratio test next. I heart alternating series. In fact, I love alternating series so much, I would put it way up there because it's so easy. Ratio test and in using partial sums, those are really low on my list. I'm not going to go there unless I absolutely have to. Well, the thing is, while the alternating series test will tell you whether something converges or not, when there's an x in the series, it doesn't tell you where it converges. So I'm not, this is the guidelines for saying does it converge? The question, where does it converge, is something I only answer using the ratio test. All right. But there is a way of proceduralizing your attack on these series. and again, with the exception of me moving the alternating series stuff a little bit higher, not too bad. Not too bad. All right. You have now the ability to finish off this homework. We are all done with chapter number 9.
Huzzah.
Huzzah is correct. We've got 3 more sections to get through before AP test day. No, it's stupid that I didn't plan better and we didn't have more time. But we'll get you the content. I want you to know that you have at your disposal right now 95% of the content that's on the AP exam. Right? You really do. This last little stuff is some little piddling stuff. In fact, there's no actually consistent theme in chapter 10. It's kind of like a little bit of this, a little bit of that. Right? But you've got 95% of the content. You have enough for a 5. If we get everything right that you know. Sorry. If you get everything right that we covered, you've got enough for a 5 now. We're going to pick up some extra topics, try to increase your probabilities, and you can do it right now. All right. Why don't you get started on this homework right now?
I'm making an English study guide based on...
One second.